Yes, sir. Okay, shall we start, sir? Okay. So, good morning, sir. On behalf of Nadar Saraswathi College of Engineering Technology, I would like to welcome Dr. G.Sathish Pandian, sir, for this wonderful webinar named as Sustainable Manufacturing in this occasion. So, now I would like to welcome Dr. B. Radhakrishnan, sir, to give a welcome address. Sir, please, sir.
Yes, sir. Sir, is it audible for you?
Yes, sir. Yes, sir.
Audible, sir.
Yes, sir. Thank you, sir. Thank you, Venimalajan, sir. I would like to welcome all on behalf of Nadar Saraswathi College of Engineering and Technology for this wonderful occasion. I would like to welcome our secretary and joint secretary and principal, sir, for this wonderful occasion. And also, I welcome our chief guest, Dr. G.Sathish Pandian, Director IQAC, Department of Mechanical and Automation, the PSN Engineering College. I will welcome you, sir. Now I hand over session to Mr. Dr. Sivagandan, sir, for this chief guest address. Thank you, sir.
Thank you, Dr. Radhakrishnan, sir. It is my immense pleasure to introduce our chief guest, Dr. G.Sathish Pandian. Now I would like to introduce our chief guest, Dr. G.Sathish Pandian. Started his schooling in Oxford Metric School, Chennai, and completed his secondary and higher secondary in Rosemary Metric Higher Secondary School in Tirunelveli. He is graduated from Bharat Institute of Science and Technology in the year 2006, Chennai, and did his master in Tyagarajar College of Engineering, Madurai, and passed out in the year 2010. He got selected as project fellow in a UGC major research project during 2010 to 2013 and completed his doctorate degree in the same title in the year 2015. Also, he has served as teaching associate in Tyagarajar College of Engineering, Madurai for 2 years during his full-time research tenure. He is joined in VSP Engineering College as associate professor in the year 2016 and served for 5 years and relocate his job location to Tirunelveli in the year 2021 and serving as professor of mechanical and automation and director IQAC since September 2021. For his academic credentials, he has published more than 10 articles in SCI and around 20 articles in other reputed journals. Got fund from AISTE, Modroff for academic year 2019-20 for an amount of rupees 15 lakh. He has delivered several lectures in various engineering and polytechnic institutions. Received grant from AICT Modroff, rupees 15 lakh 55,686, Manufacturing Lab 2019-20. Recognized research supervisor faculty of mechanical engineering, Anna University, Chennai, register number 2920040. Organized a national level workshop on recent trends in renewable source of energy 2018 at VSB College, Karur. Coordinated for the International Conference ORURD 2010 TCE Madurai. Coordinated as organizing secretary for the International Conference ICRIETMS 2022 PSN Engineering College, Tirunelveli. Sir also a member in Institute of Engineers and ORSI. Thank you, sir. Thank you very much.
Thank you, sir. I hand over the session to our chief guest, Dr. G.Sathish Pandian, sir. Sir. Sir, kindly share your PPT, sir. Satish Pandian, sir. Sir, Satish Pandian, sir, your mic is in off condition, sir. Just unmute your mic, sir.
Excuse me,
Yes,
Satish,
sorry.
Satish sir, your voice is not audible to us.
Sir, is it now is it also audible?
Now it is audible, sir.
Oh, thank you, sir. So today, can you hear me?
Sir,
Okay.
Yes, sir. Yes, sir. You're audible, sir. Yes, sir.
First of all, I would like to thank the organizers of the management, National Nadar College of Engineering and Technology, Mr. KPR Mungan, President PM HLU, Mr. T. Rajmohan, General Secretary, PM HLU, Mr. N. Palaniappan, Treasurer, PM HLU, Mr. K.S. Prabhu, Secretary, Saraswathi College of Engineering and Technology, Mr. A. Rajkumar, Joint Secretary, Saraswathi College of Engineering and Technology, and respected Dr. C. Nadar, sir, Principal sir, Saraswathi College of Engineering and Technology, and the HOD of the Mechanical Department, Mr. A. Raj is and the coordinators, Mr. A. Vandimani Rajan, and Mr. J. Chakravarti Samudra, sir. So this is my so should be the first slide to thank the management of NSCET to inviting me for this. So today's webinar is about a sustainable manufacturing. Here I want, yes. Sure. Wait a minute. Oh, it's not. So the audio is okay, or is
Sir, your voices are not audible, sir. Satish Pandian, sir.
sir, still your mic is mute, sir. Satish, sir. Sir, just go to that meeting and unmute yourself, sir. and continued that seminar, sir. It's a request.
Can you hear me, sir? Oh, okay. Thank you. Thank you. So I welcome you all for this webinar on sustainable manufacturing. Hope Dr. Sir have introduced about myself. And here I am as a Director IQAC and Professor of Mechanical and Automation Engineering, Ph.D. Engineering College. So on behalf of Ph.D. Engineering College, I would like to thank our management, principal, the HODs, and my colleagues to encourage and support for this particular thing. And especially my thanks to Dr. Dhanabal, of my colleague, who collaborated me with this event. This is my special thanks to NSC, Saraswathi College of Engineering and Technology, and the team. So here, I wish to introduce the very common topic. It may be sustainable manufacturing. Hope you can see variety of manufacturing techniques or manufacturing terminologies or other related manufacturing areas, which may be of lean manufacturing or green manufacturing or whatever else, especially the target audience. I understand that the target audience are mechanical engineers. I understand that they come across various terminologies. Before that, I want to state something about sustainable manufacturing. The creation of manufactured products through economically sound processes. It is not a general process, general procedure. Should be a economically sound process that minimizes negative environmental impacts while conserving energy and natural resources. So it is not as things goes like if we have to manufacture certain products, we should be satisfying customer needs. That is not only the prime objective of any manufacturing or any sustainable or green or lean manufacturing. The main thing is to understand that it should be economically sound. In the same sense, it should not impact negatively with the environments. As we all very aware that the manufacturing or other kinds of maybe infrastructure developments or in any country or any advancements aiming to superpowers in the world is destroying the natural or other natural available resources. The depletion of natural resources or impacting the environment, existing environment leads to it is not a sustainable growth for any particular nation. So we must be knowing what is economically sound processes that should not compromises the impacts on environment and depletion of natural resources. So this is what the base. It should be concentrating on all those economical, social, and environment. The theme is comprising of all those three aspects of economical growth. So, as everybody knows that sustainability, the term is reaching everywhere in the recent decades. It is because of the one side we know that all the developments, infrastructure or the manufacturing or in terms of any kind of automotive or even in agriculture or in other domains, we need a heavy growth irrespective of the environmental degradation or the natural resources depletion. Even in agriculture, we need to have tons of outputs within a specific space, maybe of 1 acre of land. We are expecting, the people are expecting, or the government are expecting some multiples of tons of outputs. So we are using a large amount of pesticides or large amount of fertilizers or large amount of things which is harming to the soil, harming the water, or harming the space or the gas. So irrespective of considering this environmental degradations, we cannot achieve anything else. So people are now going for organic products, which is not mixed with all those environmental degradation or harming or pesticides like those things which is not exposed to this particular the grains or which is available in the particular agricultural land. So here we can say that I was telling about the examples in agriculture. The same thing is we can imagine that for manufacturing, we can understand that large amount of effluents or the waste materials as scraps or even like paints or anything else is collected as a large amount of waste or the scrap which cannot be recycled or reproduced, reused. So for that, the governments or the stakeholders or decision makers are going for as a term sustainability. As you can see this slide, sustainability is the conscious and proactive use of methods that do not harm people, planet, or profit while also leaving a positive impact. Here, there is no compromise for economic as well as social as well as the environment. Here, that is the conscious, that is the humans can think about or they can use of the sense or they can be conscious about their environment without compromising the positive impact on environment, whereas the human harm human. The things which just comes as scrap or anything else should not harm the human nature or the entire planet. That is what here the stressed word sustainability is termed for any agricultural or industrial or infrastructure or manufacturing domains. So we need to understand about that sustainability. It is not only the thing which we come across in the latest slides is it is not the word, it is not to be achieved, it is to be continuously practiced. Sustainability, even for engineering, academics. If a particular industry, if a particular institution is stopped in this particular academic year, that is not just achieved. It should be sustained for all the years. In 2010, our college was the first in Tirunelveli region or Madurai region or Tirunelveli region is not the particular sustaining the position, but sustaining the position all throughout the years where it still exists is the matter, and it will be suitable for manufacturing or for the agriculture or whatever else we consider. It is a common terminology for every domains that we access in day-to-day life. Even for automobiles or mobile phones, we can say that some kind of some brand of mobile phone is still to be the top in sales or in top into the user friendly or top in other aspects. So it is not just that the last year a particular company is good in sales, or in 4 years back some companies top in sales. It is not that the meaning is sustainability is mean that it should be sustained in all years and all periods. That's what here to be stated here. From this we can evolving and we are confining to mechanical engineers. The sustainability term is common to all aspects, but we are confined to manufacturing and we are going to move to the next slides. So it can be stated that as I said earlier, manufacturing technologies are wider, like green manufacturing or lean manufacturing, maybe additive manufacturing, remanufacturing. We have a variety of terminologies that is used for manufacturing. As I said, as in the slide, you can see that for example, green manufacturing, it states that it is the renewal of production processes and the establishment of environmentally friendly operations. So the green manufacturing is maximum. It is focused on operations that is to be considered as green. Use of fluids, or some other components. You may use variety of fluids or materials, kind of all those things that we can say that 4M or 5M, all kind of M's to be used in an effective manner. So it is concentrating on operations. The green manufacturing is concentrating on operations, whereas next one is lean manufacturing. It always can say that it's a production process based on ideology of maximizing productivity while simultaneously minimizing waste. Yes, there exists a particular operation or a processes where the objective of this lean manufacturing is to minimize waste. So maximum utilization of the raw materials, maximum utilization of the fluids that is used in this particular process. So every terminologies, as usual, we can say that additive manufacturing or remanufacturing. Say for example, remanufacturing is collecting of all those recycled contents, or it may be considered to be as scrap. All those scraps or other things can be collected. Those materials can be put into a process, and it should be reused by the particular company or otherwise. So it is also a kind of minimizing waste and a reusing of this particular thing. So we can say that remanufacturing is also a objective one. It is termed from the industry acts or other stakeholders. They impose on these industries to forcing the industries to go for remanufacturing, or ultimately we can say that industry 4.0 or something like that. So that adopts all those processes or operations or any kind of technologies that minimizes the waste and other concepts. So it is also various from these various manufacturing terminologies we can come across a sustainable manufacturing. Right, we can say that green manufacturing, remanufacturing, additive, or many kinds of manufacturing. So among this, what do you mean by sustainable manufacturing? We know about sustainability, and we have gone through the first slide, sustainable manufacturing and this definitions. But we have to think about what is sustainable manufacturing. That is today's topic too. So we need to consider some a basic information about the sustainable manufacturing and what it is. So that is the objective of this presentation. I want to explain that in a simple word. I can say that all these terminologies, what may be lean manufacturing, green manufacturing, or remanufacturing, or whatever it is, from the first slide, I can say that social, economical, and environmental. The process or the product or the service which do not harm all those things. Any industry is focusing on manufacturing the product which should be sold to the customers, and from that it should be make some profit from that. So it is a basic thing. I can say that here in this slide, you can say that economical aspects. Here we can see that the left-hand portion, we can say that economic aspects, cost, quality, and tool life, and etc. It focuses on all those things, right from the collection of basic raw materials. It may be aluminum or iron or something else. The basic raw materials, the additional raw materials that is required for process or making of products, like fluids, or for welding components, or some other lubricants, all those things to be purchased or procured in a minimum price. That is the objective of any particular manufacturing company management, so that they must procure a lesser priced component and it must be value added. As you say, as we are very well aware that value addition through various processes, manufacturing of a particular component through ferrous components, aluminum or other any composites. So going for composites or going for replacing composite materials with other materials is the trend for past several decades. So it is all because of reducing cost, and it is a part of making profit to the particular manufacturing unit or particular any companies. The same sense, any company should not go for any kind of device which will harm environment or social. In the social, in the respect, we can say that the next slide, the center one is where we have social. Here we can concentrate about the manufactured products while using or while manufacturing or in the stage of recycling, it should not harm the nature. We can say that with a very simple example, all we know this, manufacturing of a current or electricity from various things like hydroelectric, thermal, and even nuclear, all those things we have. So the main reason in nuclear power plant, the collection of waste from the nuclear power plant cannot be dumped somewhere else. Is as we are all aware that it is definitely harming the human nature. It may be of sea life, or it may be of animals or trees or anything else. So we are considering, as a manufacturer, we have to consider all the stages from manufacturing the product, usage of product by the customer, and also the product when it is disposed. So all three stages to be considered. Whenever the stage is used by any particular human or something somewhere in the particular domain, we cannot say that it should harm to the sea life. The ecosystem is not built for any particular human. It is all comprising of all those things. So the three stages to be considered as all is comprising of a term, simple term, social, and is directly or indirectly impacting on it should be positive or negative. That's the way. It should not be negatively impacting the environmental by decomposing or exposing the components. It may be of a scrapped item to the environment. It should not harm any fauna or flora, all those things. So it is a basic necessary. I'm coming from top to bottom. Here I can say that these are the basics: economic, social, and environmental circles. We can say that are circles which will interlink, and it cannot be harming any way to the human. So that is, we have the manufacturer should be keen in identifying all those raw materials and manufacturing of those raw materials and disposing of these raw materials or the manufactured product. So the manufacturer must be considering or comprising all those three aspects. So here the sustainability is, as I said earlier, comprising of all these three, and we are practicing or converting the conventional method of manufacturing to a very drastic or very changeable manufacturing techniques. As we are now, we can say that Industry 4.0. We have heard about this terminology, Industry 4.0, but it is very late. We commonly say that Western countries or German companies, they are far ahead, and they are practicing this Industry 4.0 almost 15 to 20 years back. We are in academics or in industry side, we are practicing in Indian or some SAARC or other countries for the past 5 to 10 years. So it is like usage of all those recent technologies. Just as a comparative statement, I can say that a particular length and breadth of a sheet metal to be used for a particular dyeing thing, a manual can use his own techniques to identify all those places or all the shapes and sizes to collect all those necessary required shape and size from a particular sheet. If you go for a particular robot or any other advanced technologies, like even now we can say that artificial intelligence or other terminologies are used in manufacturing. So they identify precisely and utilize maximum amount of sheet metal for their cutting or usage of particular devices or manufacturing devices. So that is advancements. Here, a particular example is conveyed to you from changing to conventional to latest technology, which is using or IoT or artificial intelligence for maximum utilization of particular sheet metal. So this is a one single example that we can use for reducing of wastage of the particular sheet metal. As we all very well know that even if it can be compared with the composite material. The same thing is a composite material. If you have a particular length and breadth of a particular sheet, composite material, the composite material should be maximum utilized. As many professors are doing composite as their research area, they know we need the requirement of composite and its research in the particular decades. But in the parallel side, we need to parallelly we have to check the environmental impacts of composite materials. It may be it may not be a natural composites, but the artificial or other kind of composite materials might be harmful to the environment when it is composed or it is burnt out or something else. So people are studying or people are doing the research and finding out maybe biodegradable composites, going for natural composites or something else. So the impact is the same. We are identifying for a best practice to cut all those things, all those required components from the particular sheet metal, or it may be ferrous metal, or it may be a composite material. When it is left out, the unused materials, it may be a composite or ferrous, the harmful to the society is comparatively large when it is considered to composite materials. I'm not degrading it, but it's a necessary product for this particular season. But my opinion is to consider the environmental impacts and go for natural resources. It is not degrading any kind of thing, but it's a general study. The need of the hour is composite material, but in the same sense, it should not harm. It should be a sustainable material to be manufactured. So we are concentrating about product, process, and all services, including all those aspects, as I said earlier, economic, social, and environmental. Also, all those three should be complied to manufacturing all those things. Then I think that this is a need to talk about sustainable manufacturing. Most webinars or something else are talking about various domains. It may be of infrastructure, manufacturing of things, or composite materials, or thermal, or domains. All domains are the primary purpose is to manufacturing a particular product which should be cost effective. The basic thing for all research domains is to identify a particular component, a replacement of a particular component that should be cost minimum and to withstand all those physical and chemical characteristics. So that is the need of the however, like any other industry, the sector consumes a great number of resources while generating a large waste leading to environmental damage. Thus, it is imperative that is more important that manufacturing industries strive for sustainable manufacturing on an immediate basis. As I can say that this is a hover to adopt these sustainable manufacturing techniques by all manufacturing units. It may be of automobile or sheet metal manufacturing or all kinds. It is not confined to some particular automotive or something like that. It is a common for, as I said earlier, it is also for agriculture, medical, and automobile and other concepts. But now we are confining to some basic mechanical operations. So here it is required. Who insists or what are all the possibilities to identify about sustainable manufacturing and other concepts? Industry may be conducting conferences, webinars, or other such gatherings where the industries can discuss on their own, or even with the government officials. We may be call it as stakeholders, the decision makers, the policy makers. The rules and regulations framed by the government or the non-governmental organizations or even the industrial associations, maybe like a confederation of industries and Indian institutions, confederation of industries, and even other various professional bodies confining to manufacturing or civil or something else like. So these are all the stakeholders which sit together to frame all those things. They form rules and regulations which are very much needed to this particular hub. So the system is comprising of all those things. As I said earlier, a society is comprising of all those things. Yeah, a society should be comprising of human their needs. As you guys said, that all these things, the basic things is dress we need, components we need, food we need, all those things. So it should be gathered, it should be collected, or it should be purchased by the common human for their beneficial, and it should not harm to this human society in any matter. So that those responsibilities can be collected by all those stakeholders or the policy makers. They sit together and frame all those things. The evolution of industrial revolution, or from that to the industry 4.0, and still it is going to be converted. Maybe for industry 5.0 or industry 6.0. It is not, as I said earlier, sustainability is not a common thing which cannot be achieved. It should be practiced all the way. It should not stop somewhere else. While comparing all those colleges, I said that it is not referring a particular year or referring particular this year. It should be sustained all those years. So the stakeholders like government agencies or other pollution bodies, they go for a research. And there are departments like chemistry, or department like pollution, or department like mechanical. All those kind of departments are the environmental friendly researchers are drastically moving. I can say that some Indo-Germany chapter for sustainability manufacturing. In many countries, they have a particular department, even in the ministerial level, they are having a sustainable manufacturing units in collaboration with various industries. Like I said, in the Indo-German collaboration, Indo-Japan or Japan or Germany, all those comprising industries are collaborating each other to frame all those sustainable manufacturing techniques or terminologies that can be distributed along through the globe, so that every industries can adopt such practices. The ultimate goal of this particular thing is to reduce all environmental impacts without compromising the economical benefits to the particular industry. I can say that some implementation of Industry 4.0 is built off all those IoT-based technologies, or use of artificial intelligence, or many technologies, machine learning, all those things in the collaboration of a CSE or IT and mechatronics and mechanical. The collaboration of two different departments gives you various newer technologies that is benefit to the manufacturer and to the society. As we are very aware that industrial waste is a huge for this natural disaster. Hope you will agree with this point that we can state that some millions or trillions of tons of waste is collected every day. I can say that we have a line that 15 million tons of 15 million. It's not a million. It's 15 million of tons of industrial waste is generated every year in London. They are very much conscious about environmental impacts. In this particular country, as Britain, it states that 15 million tons of waste is generated every day through various, it may be of automobile or something else. But while comparing Britain versus India, can you able to think that what will be the calculation? As for Britain, it is 50 million tons. What will be the capacity of Indian industries waste? Just imagine if you can able to send any messages, come to chat box. So I just want to compare it. A small nation which is more conscious to the environment is generating 50 million tons, and we can extend it to that. The technologies which they are used for the recycling and other processes may be far better compared to India. But we are generating a huge amount while comparing to London. But we have to be implementing all those newer technologies like maybe clean technology or lean technology or this sustainable manufacturing technologies to reduce the waste. Eliminating of waste or maximum utilization of raw materials is a primary objective. All those terminologies we are heard about, especially in academics, we are very much aware about all those terminologies. If anybody is asked about green manufacturing or lean manufacturing or sustainable manufacturing, anyone can state the definition or anything like that. But practicing of all those terminologies is much harder because of compromising the economical aspects. The competitive world, industries are fighting with each other to become number one in all aspects, in profits or in market leaders or in all aspects. So the industrialists and the academicians have to collaborate each other to concentrate on these terminologies, industrial waste, and we have to suggest our research ideas or the research outcomes that should benefit the industrialist or any other manufacturer to reduce or eliminate this industrial waste. So we have to concentrate all those things. And we can say that it is not only the scrap or the fluids that is considered to be the waste. As we are well aware that soil, air, and water are polluted by this environmental degradation. I can say that a liquid waste, it may be of all those wastewater, organic fluids, detergents, and the fluids which is used as coolants for the particular Very sir.
Sir?
Sir, can you hear me?
Yes, sir. You're audible, sir. So kindly
Okay.
share your picture, sir.
Okay. Can you able to see this?
Yes, sir. If it is visible,
Okay,
sir.
sir. Okay, sir.
Okay, sir. Thanks, sir. Continue, sir.
Okay. I will restart. So now we can see that few types of industrial waste, like liquid, solid, and all those waste which is generated from industries as waste during process and off processes. Here, the remedies for this too, we can say that industrialists and other stakeholders have termed this all those sustainable manufacturing by linking innovation. As I said earlier, innovation and technological automation, it is not from the a particular department. It is comprising of all those mechanical or mechatronics or computer science and industry, information technology, all those things. Every as researchers all know that many algorithms or many new terminologies which is invaded to the manufacturing sector. If in a particular maybe a tractor manufacturing company, you might have gone for any industry visits or something like that. You can come across any, especially with the automobile sector. We have heard about that every 3 or every 2 minutes or every 1 minute, a particular component is manufactured and delivered every 10 minutes. That is completely in a stretch of, it may be of a meters, 100 meters or 200 meters. A particular component is assembled right from a particular point, zero position, and to it extends, it should travel for a distance of 100 or 200 or 300 meters and more than that. It will cross from 0 to 100 meters and it will all collected the raw materials, it will assemble and it comes to a particular inventory without any human intervention. So here, every stages, I can say that if for any particular painting or any particular welding or any particular assembly points, lesser the invasion of human and the more the invasion of technologies, automation, robots, and all the technologies are invaded into the manufacturing, all because of reducing the cost, reducing the waste, and minimal use of all those components or the fluids which are more harmful to the environment. Reduction of, at least we can say that cannot those materials which are harmful to the nature cannot be eliminated thoroughly, but it can be reduced to an extent. So that is the objective of all those manufacturers. Day by day, they are going on research to reduce. The final thing is to reduce all those harmful liquids or harmful materials, but they can, without compromising all those economical aspects, they are invading into all those every section of the particular process. We can segregate all those processes, maybe of production or a painting or quality, all those things. All those departments come together or in collaboration with all those things. They are trying to eliminate all those things. Is the objective of, or it is the waste which is stressing from the stakeholders or other policy makers, decision makers, to involve all those technologies or innovative techniques to minimize all those the things to be considered as harmful to the environment. Here also we can say that as stated here, it is not the particular section all generation of waste are collected. It is from all those areas. Even it can be considered for a packaging. We can say the ink used in packaging or the materials used for packaging or the materials to wind up the packaging, all those things are maybe it cannot be degraded easily, or it should be replaced, or it should be recycled, all those things. So right from collection of raw materials, it is also consisting of a particular packaging system. It should be backed very well. It may be of a very common visible products like thermocool or the twines which is used for wounding the packages, printings, the inks used for printing, are all kinds of materials that is used. Say for particularly this kind of section is also leads to harm the nature in a drastic mode. And next I can say that here many aspects to be considered, that is economical, social and environmental. We can say that waste from industries, it may be of lesser proportion, and even from biomedical, the biomedical waste, the proportion of waste may be very less compared to manufacturing units or other auto. Manufacturing units or automobile, something like that. And even when we go for nuclear power plants, we can say that the waste is very less, but the radioactive the waves or the other harmful rays are much bigger than the waste which is produced from manufacturing or other units. So it is not the matter of size. It is not like smaller size or larger size. The stringency of impacting the environment is to be considered. Yes, that is a balanced thing we have to consider, whether to go for economy or society and environmental. If a particular product is manufactured, we understand that it is very much essential for this human community, right? Okay, but how far this particular component is harmful to this nature. In the very recent days, a news was circulated that we humans use toothbrush, and this toothbrush is not yet degraded for so many years. Almost we can live for 60 years, but for 300 years, 300 to 250 to 300 years, the time taken to decompose a particular toothbrush, when it is considered globally, the number or the quantity which is collected as waste is unimaginable. And people are saying that the almost some 50 to 60% or more than that is collected from the seed beds everywhere. It is just thrown into the canal or thrown into the river, and it is ultimately collected in the seabeds. It is a greater ecosystem that is we are slowly degrading it, and we are facing the conflicts from the particular degrading of all those seabeds and other things. Yes, we have to concentrate on human needs. We are manufacturing various kinds of products for the betterment of the society. Ultimately, we also have to concentrate on environmental, as this is the chance for this particular students of this particular manufacturing or mechanical engineering graduates. Keep in mind that you may be selected in various companies. It may be of IT, even for IT companies, or even for mechanical or automobile or any other companies. Keep in mind that environment is to be concentrated, and environment is to be it should be in a safer hands. So in every aspect, you may be in a design engineer, you may be a design engineer, you may be a production engineer, or you may be a quality engineer. All those things you are used for production or process or quality, all those things. Keep in mind that everywhere you have to keep in mind that the particular device or a particular component which is coming out to the customer as an end product, it should not harm the particular human or the society in any kind of matter. So that is the responsibility of any engineer, to be very cautious about environmental and those things. Definitely, the product maybe definitely impacting social, so society or the environment. All it comprises all the things. It comes back to the particular company. If any component is found to be very harmful to the society, definitely the stakeholders or the regulatory policy makers will imposing fine is not the simple matter, and it will be exposed to the society, and definitely the product will not be further sold to the customer. That is to be very highly conscious about this particular component. And we can say that it's comprised of all those things. What does sustainable manufacturing mean in practice? In every aspect. That's what we have mentioned. It is not only a collection of effluents from the industry, and it should be sent to the effluent plant, and it should be recycled. It is not only with respect to the effluents which is left out from the manufacturing unit. That is not only the case. We are concentrating about sustainable manufacturing. That is not only the environmental caring practice, but it starts from sustainable manufacturing all of the life cycle. As we all know that life cycle begins with a particular collection of raw materials. Collection of raw materials, we can say that maybe collection of coals, collection of ferrous materials, iron, all those things too. Once again, it gets manufactured, the products are used by the customer, then it comes back as obsolete material, and it is decomposed. It is a complete cycle. Everywhere you have to concentrate sustainable. While digging off all those ferrous materials, you have to think about sustainability. As we are very much aware that we have to sustain the resources which is available in the environment. We should not deplete all those things. So all these things to be concentrated. Sustainable manufacturing along the life cycle is using less packages, lowering of product weight, minimizing of weight, as it comprises of different domain study. As we compare about composite materials, the main objective is to lowering the weight without compromising all those physical and chemical characteristics. Replacing of ferrous, replacing of aluminum, or replacing of some other XY materials with all those materials. The main purpose is to using lowering product weight. Less weight, minimizing weight. As you know very well that automobile companies are replacing every component with composite materials or other particular material to lower the weight, so that increasing the fuel efficiency or fuel economy. And next thing is using more efficient transportation logistics. It should not be think that the distribution of logistics comprising that is a different section. As you know that Anna University has a separate department for packaging and printing. So you must be aware that a particular department is evolved for this particular section, like packaging and printing. You must think that how extent the particular department is widely used across all those kinds of industries. So every fewer material, every fewer sections, this sustainability has to be implied or empowered, so that it should be considered everywhere. So use of less energy and water, reducing modified production processes to produce less weight, renewable use of renewable materials. Excuse me. And here we have a common steps to adopt these sustainable manufacturing practices. While coming to a particular point, I can say that sustainable manufacturing, the very common thing I can say is sustainability starts from your home, your own individual characteristics, your own behavior. Even it is applied for academics, industry, and other aspects. All aspects we can use this sustainable word or the sustainability. Yes, if a particular resource is available, so making use of this for a maximum period is sustainability. If you can say that a particular component is available in plenty, so that you cannot exploit it in the same sense, then definitely we will go and stand a particular period where that product cannot be exist everywhere. So we have a practice of 7 action steps to sustainable manufacturing. The first is to prepare, as I can say that here, prepare, measure and improve. And it is not a a particular, it cannot be stopped in a particular point, as it states that it is a continuous process. As you can say, that we have studied in TQM or POM or something somewhere else. Everywhere it says that there is no a single point to start and single point to end. Many good characteristics are a continuing process. Similar to that, we have a sustainable manufacturing is also a continuous process where we can follow seven steps, as I have to say this. First one is map your impact and set priorities. So here, I can compare it with once you enter into the company, you can know about all those company or the manufacturing setup, all those seconds that are used can be studied. But prior to that, we can say that as any institution as a company, we can compare it and we can study that will gives you more information or more interesting to adopt what is kind of this sustainability team or sustainable group, we can say that. In a particular industry or in a particular institution, everywhere we have a particular group. Then maybe in this institution we have all those management hierarchy charts, management, then the principal, then the HODs, then the professors, all those things. The flow of information from one point to other point is very particularly defined, and it also says that it is a team. Everywhere it is an academic team which purposefully made to transfer knowledge to the students, make them well versed in the particular domain, and the people to be industry ready. So likewise, even in sustainable manufacturing, industries should have a particular sustainability team. Especially, it is not dependent. It's not only for the production team or the quality team or the design team. It should comprises the overall system should be monitored by this team. So every individual, even house, our father or mother, or even the grandparents or the management team, which that particular group will decide on their own for making a particular decision. Likewise, CAI or all other any other professional bodies, they form a particular group. They dilutes all to this particular environment or the responsible sustainability team to form in particular industry, so that it particularly monitors all those activities in every department of this manufacturing unit. So it periodically observes all those things about what is to be done, and the periodic review. Yes, you may be aware that every industry, in every morning the people will be having a meeting for the particular day's event to be considered. What is the objective of this particular day? What is to be carried out? What is to be completed? And the evening meeting, every activity will be reviewed, and the review remarks will be considered. And the next day, this misleading should not be carried out to the next day. So a review, setting objectives and performing it and reviewing for this particular day is very, very important to be considered by this sustainability team. It is not only for manufacturing, it can be practiced by any particular individual. That is what we can say, that in the morning we will make a plan, or we will map the road path from morning to evening. What are to be done? What is to be communicated? What is to be completed today? What is to be completed in this particular week or the month? So all this to be the priorities should be set up, and this should be reviewed. What is to be done today? Have it to be done in this particular evening or in this particular end of this week. All things to be reviewed. It's a systematic procedure that is to be carried out by this sustainability team. Next one is select useful performance indicators. Indicators is a very common thing that I can very good example is a component manufactured by any particular company. It may be of your two-wheelers. All things are fixed in a designed manner, and you can see that you can see all those indicators. Maybe your fuel indicators, or the speedometer, or the odometer, or you have many sensors built in. That indicators are very essential for this particular automobile. We should agree all those things. If you go across, if the speed exceeded 80 or 120, definitely it harms the nature. How it is harming the nature? Unburned fuels, which is mixed with the environment. It is also harming the engine. It is also harming the human who rides the vehicle. It may be causing any accidents or something else. All small indicators which is given to us from this particular manufacturer. They give all those indicators to follow all those instructions. We are all educated and we are relying on those particular indicators. Yes, the fuel indicator shows or indicates very less indication. So ultimately we have to approach any fuel bunks and we have to refill it. Likewise, every indicators are alarming our activities. That is, we have to compare with the manufacturing. We have to monitor all those things through all those indicators which are fixed with it. Measure the inputs used in production, right? We are repeatedly using all those raw material. We are discussing about raw materials and its ultimate components which are used and the final scrap items or the obsolete items. So we have to concentrate. Initially, we have to concentrate. It cannot modify into a better, even a ferrous material cannot get benefited while coming to the scrap. A scrap is a scrap. The ferrous material cannot convert it into a natural friendly one. Or the composite which is manufactured or which is selected as raw material cannot be converted into a beneficial material. But from the point where the raw materials are selected to be well selected as that should be very friendly to the society or friendly to the environment. Next, assess operations of your facility. Repeatedly, I can say that sustainable manufacturing comprises it's not only the process or product or other scrap item. Every products or every techniques or every terminologies which is used as recent technologies adopted in manufacturing. Yes, all those manufacturing techniques to be considering in mind environmental or other environment friendly aspects. A component can be used. A new effluent or the new fluids can be identified. We should not harm the water. It should not be a water pollution. So research is going on for finding a replacement of fluids, cutting fluids. Normally we will call it as cutting fluids, which should be environmental friendly. Yes, many researchers are going for oils which is from collected from trees or other components, which is environmental friendly. Ultimately, we have said that almost I think that greenhouse gas emissions from air conditioners and refrigerators is almost completely eradicated. Now there is no greenhouse gas emissions from these air conditioners or refrigerators. Likewise, we have to the researchers, the academicians part is very important. Now manufacturing units are recruiting many researchers or the masters in a particular domain to exclusively for R&D section to finding out alternatives for such emissions or emissions to air, water and soil. So it is our responsibility to identify all those alternatives for particular harmful raw materials which is used for manufacturing or any other kind of products. Evaluate your products, right? Here we can say that lowering of energy consumption. It is also an aspect. Consumption of low energy, low raw materials, low fluids. We can compare with other methodologies of adapting manufacturing. Lesser use of the term is productivity. Lesser use of raw materials and gaining out maximum from the particular device is also considered to be productive. Understand measured results. Read and interpret your indicators and understand trends in performance. Okay, as I said earlier, it is not a a thing that is to be achieved, but it should be practiced it's a continuous process. So the indicators to be fixed everywhere. It should be alarm to you whenever you cross the boundaries. Say for example, you can say you can fix some device, and you have to check that pH should be 7 or 8. It should not exceed, or it should be reduced. So that's the pH indicator should be always there to alarm you whenever it raises or reduces. It is a simple example. So there should be an indicator. Likewise, in your automobile or car, everywhere the indication is always there to check and indicate your performance. Next one is take action to improve performance. If whenever you find any issue in crossing the boundaries, maybe beyond the particular point or lesser the point, so if it happens frequently, then you should change the technology that is adopted. You have to go for a recent technology or the recent process that should minimize those indicators that is frequently alarming you. So these are all some 7 points that is to be followed, and it should be continuously processed to achieve sustainable manufacturing. Here I can say that, as I said earlier, it should be concentrated in all aspects: inputs, the process, and the products. Here you can say the many points it is stated that use of non-renewable materials, recycled or use of materials. Likewise, from this to products indicators, everywhere we have some points. We should fix some indicators that should alarm us and to check and replace technology, either for either technology or some other things. Even here in the P5 states that restricted substances content. So some fluents, as we must be very knowing that it is definitely harming the nature. Completely such items to be reduced or eradicated. So likewise, we have to check all those things. You can paste it in your home or in a manufacturing unit or somewhere in the office, somewhere in your office. Do's and don'ts. We may come across many do's and don'ts in any particular area, even in particular section. Some before entering that, we may see some do's and don'ts. Wear helmets or wear precautionary items, or like COVID-19, which doctors wearing all those PP kits or something else to enter into the section. So likewise, we have to indicate everywhere what are all the things to be done, what are all the things that is not to be done, and you have a particular indications that to guide, review, and monitor all those things. And here further, it is, as I said earlier, it is a continuous process. There is no start and end point here. Monitoring process to waste. The process to waste is not there is no particular starting point or no particular end point. All those things from process optimization, energy efficiency, eco design, industrial symbiosis. Industrial symbiosis in the sense we can adopt practices or the technologies that is practiced earlier by the industry. It may be a benchmark industry. Then the waste reduction. It is not only confining with the process or energy consumption or industry or something like that. It is a complete process. All those things to be concentrated. And it is repeatedly says that sustainability is a journey and not a destination. Here we can say that, remember, there's no such thing as a company with no environmental impacts. There is no sustainability destination. Everywhere we are finding alternates. We have no sufficient raw materials. It may be of ferrous or it may be of coal or something like that. So with the existing resources, we have to sustain our societal needs without compromising environment. That is the need of the hour, and we have to concentrate. Implementing of sustainable manufacturing is with respect to changing to new technologies. It may be using the technology may be using lesser cutting fluids, lesser materials, in the sense optimal use of materials. Like I said earlier, a sheet metal can be utilized more, leaving lesser residuals or lesser unused components in the raw material substitution. Drastic composite material research is continuously studying to replace all those existing composite materials, maybe eco-friendly materials or something like that. Next, to shifting to more environmentally sound inputs. Ultimately, it is the main thing. We are going to focus only on environmental friendly practices, environmental friendly design, environmental friendly raw materials that is to be used and that is to be used by the customers, and then ultimately it has to be dumped somewhere else, and those dumps should not harm the nature, and it's friendly decomposing all those things. Outcomes should be, as I said, as this presentation might be just kindling your lesser information about sustainable manufacturing. At least there's a lesser information about this sustainable manufacturing, how SM can be practiced, sustainable manufacturing can be practiced in your home or how or a company or everywhere. And you must maybe knowing the need of sustainable manufacturing. So you keep in mind that everywhere, it may be your home, throwing out of garbages to the nearer empty plots, or throwing the waste, plastic waste, or somewhere into the area is also a harming to the nature one. So it should be practiced. You first, the sustainability should be started right from your home, then to your society, then to the, and ultimately it will compromise. It should not compromise the environment's degradation or negative impacts to the environment. So the practice, it is not a it's not a start and end point. It is a continuous practice. Everybody has to be practicing all those things. So you first initially set some sustainable goals wherever you are there. Set the sustainable goals, then practice on your daily activities. So thank you for this presentation. I would like to get any feedbacks from this from the participants who are there. Still, if you have any further queries, you may mail to this gspmech@gmail.com, sorry, yahoo.com, or even gmail.com. Yeah. So now we have any sessions with the stipulated time. Almost it's time there. We have 5 minutes. We will have any session, interactive session. Please.
Yes, sir. Sir, am I audible, sir?
Yes, sir.
Sir, thanks, sir. Thanks for the informative session, sir. Next, I would like to invite Mr. Karthik Raja, Assistant Professor, Department of Mechanical Engineering, to carry over the questionnaire section, sir.
Please.
Good morning, sir.
Good morning, sir.
Yes, I am audible. Sir, there
Yes,
were
sir.
a few questions from our participants, sir. The first question is, some of the challenges of sustainable manufacturing in India are lack of standards value or benchmark. And second one is end-to-end engineering. These are the
So the first one is no benchmark companies, right? So you have made 2 questions. One is there is no sufficient benchmark companies. Am I right?
yes, sir. There is no sufficient benchmark in India, sir. And the second one is end-to-end engineering. So how to overcome these challenges?
Second one I am not audible.
End-to-end engineering.
Okay.
Okay.
Sir, as we are as engineers, we are very much aware that we have a global links. Like we are adopting German technologies, we are adopting Japan technologies. So these many conferences which are organized globally are participated by our industrial persons globally. So they're still adopting all those technologies. We are here to adopt Industry 4.0, and we have many expertise in all those artificial intelligence or machine learning or all those aspects. We have resource persons. But the thing is, we have to collaborate all those things with the decision makers, maybe the government regulations, or we have to rely with the policymakers' decisions. All those things to be considered. And here we can say that the thing I am not blaming is anyhow we have to study the basic procedures or processes that is to be known by any particular mechanical engineer. Right from your manufacturing technology lab, we are practicing with the conventional lathe machines. Okay, right. But even in the industry, they have gone somewhere else. They are going for manufacturing. They are practicing industry 4.0 or something else. Definitely, we have a gap. But such seminars or conferences, the proactive involvement of the students or the our faculty members to reach out all those things and filling up of these gaps to be is to be encouraged in every the institution, so that upcoming engineers will be knowing all those things about this newer techniques or industry 4.0 or something like that. And for the first question, I can say that benchmark industries are existing in India, sir. They may be of MNCs. They can able to set up the plants in Germany with all those regulations compiled by the particular German governments. But here they have to rely on industrial regulations framed by our Indian nation. So it depends upon the geographical and other aspects. The industry has to comply with all those regulations. Only then they can practice all those newer technologies.
Okay, sir. Thank you, sir. So next question is, what are the research aspects of sustainable manufacturing?
So altogether, it cannot be. If I can say that for the research methodologies or the research domain or the research topic, we cannot give a sustainable manufacturing. But in an indirect manner, we can say that composite materials, say for example, the wider the faculty are concentrating on composite materials, in the sense that they have the objective in producing or designing or manufacturing of a particular component of a automobile or particular component of a huge machine. So it is all the thing is the decentralized, or indirectly they are concentrating on achieving sustainable manufacturing. Their objective is to manufacture a composite material which should replace a material which is already depleting the environment. So they are going to manufacture or prepare a composite material which should replace this existing material. It may be of light material, or it may be using lesser water for manufacturing, or it should withstand high heat, or many aspects. So it is directly it is not, there is no research for sustainable manufacturing, but indirectly many researchers are focusing on achieving the sustainable manufacturing in any aspect. But it is well recognized, but it's not directly stated.
Okay.
Thank you.
Sir.
Hello, sir.
So next is, what could be the future of manufacturing, either additive or subtractive?
Sir, your audio is not clear, sir.
Yes, sir. What could be the future of manufacturing?
Yes.
Either
Yes.
either additive or subtractive.
Definitely, as I said earlier, it is not confined to any particular manufacturing. Additive manufacturing is also a new technique that can use lesser amount of materials and the waste is minimized. So it is a part of these all those techniques which is evolved in the recent times, stating that moving towards sustainable manufacturing, use of lesser materials, use of necessary appropriate materials. That is the object. As you can say that additive manufacturing is using very less materials, and it can be precisely designed. So it is also every aspect is also confining or reaching towards sustainable manufacturing.
Okay, sir. Thank you, sir.
Thank you. Okay. Any other questions, sir?
Yes, sir. Thanks so much, sir.
Hello, sir.
Yes, sir.
Hello.
Hello.
Am I
Yes,
audible,
sir.
sir?
Yes, sir. Audible, sir.
Hello.
Yes, sir.
Am I audible, sir?
Yes, sir.
Hello. Hello. Good afternoon, sir.
Yes, sir. You're audible, sir.
Sir, regarding that, it's a very informative session, sir, which I learned about that sustainable manufacturing. I have one more doubt regarding about that to more know about this sustainable development in the product designs. Can you have what are the softwares we can use for the sustainability analysis?
Sir, it's not clear, sir. It's not clear. The question is not clear, sir. Please.
Hello.
Can
Sir,
you
am I
repeat
audible,
it?
sir?
Yes, sir.
Perform the sustainability analysis, sir.
Sir,
What
your
are the
voice is
softwares
not
can we
clear,
use?
sir. Let's repeat the question, sir.
Okay.
So can you repeat it again? Sir, can you able to hear?
Yes, sir.
Hello.
You're audible, sir.
Hello.
Yes, sir. Please.
Yes, sir. Yes, sir. You're audible, sir.
Oh, am
Yes,
I
sir.
audible, sir?
Could you please repeat the question, sir, please? Hello.
Sir, kindly repeat the question, sir.
Hello.
Sir, can you able to repeat the question, sir?
Okay.
Sir, kindly repeat
Hello.
the question, sir.
Hello.
Sir.
Yes, sir. You're
Sir,
audible,
what are the
sir. Kindly repeat
softwares we
the
can
question,
use to perform this sustainability analysis, sir?
Sir, indicators. Yes, sir. The thing is, it is not confined to a particular department, sir, where you can install all those sensors, or even I can say that I can give you example that for machine vision, it is also a very particular software which is used to identify the maximum utilization of materials which is existing. So it is a particular, it is not sustainable development as a whole. We cannot state any particular software or anything else. Everywhere sensors, even for automobile industries, as said in the presentation, it starts from 0.2, it may be reaching 200 or 300 meters to cover all those things. And at last it will come as a product. I think that it will consisting of 1,000 or 2,000 softwares, which all monitors every part, everywhere, and even for the fine finishing of paintings or the weldings that made by the robots can be monitored, and it is reviewed, and it will be giving the inputs to the concerned person to monitor all those things. Even in quality check, we have a number of softwares to identify all those defects or any other things, even for non-testing, distancing, and all those kinds of. It is not a single software that is used. We have many softwares which is implemented in the plant.
Okay, sir. Thank you, sir.
Okay, sir.
Yes, sir. Thank you, sir. Thank you for your informative session, sir.
Okay,
The
sir.
time to vote of thanks, sir. So thank you for your informative section. I would like to. It is my gratitude, pleasure to deliver vote of thanks. So first of all, I'd like to thank our management, our secretary, K.S. Kasi Prabhu sir, and joint secretary, Mr. Rajkumar sir, to grant this webinar in a grand success manner. I extend my sincere thanks to our enthusiastic principal, Dr. C. Madalai Sundaram sir, for being a grand success for this webinar. I would like to extend my sincere thanks to our Vice Principal, Mr. Madhavan sir, Placement Officer Karthikeyan sir, for making this webinar non-productive. I would like to extend my sincere thanks to chief guest speaker and spokesperson and Dr. G.Sathish Pandian, sir, Director of Ph.D, Department of Mechanical Engineering and Automation, and Ph.D. Engineering College, Tirunelveli. I would like to extend my sincere thanks to our head of the department, Mr. A. Venkatarajan, sir, for being a part of this webinar and make a successful webinar. Thank you, sir. And I would like to extend my sincere thanks to all the participants throughout the state. I'd like to thank all of you. Thank you, sir.
Okay, sir.
So, Satish Pandian, sir.
Hello, sir. Sir, can you hear me? Sir,
Sir.
okay, sir. Thank you, sir.
Oh, okay, sir. Thank you so much, sir.
Yes, sir. Audible, sir.
Hello, sir. May I audible, sir? Sir.
Okay, sir. Thank you.
Yes, sir. Yes, sir. Thanks, sir. Thanks for your.
Okay, sir. Thank you. Thank you.
The
Thank you for the opportunity, sir. I thank Nadar Saraswathi College of Engineering and Technology.
Okay, thank you, sir.
Okay, thank you. Thank you. Thank you, sir.
Thank you. Thank you. Thank you. Thank you so much, sir. Thank you, sir. Okay. Okay, thank you.